Trig, what's the point of all this pain and suffering and aggravation and irritation? Mugia asking you to get the sine, cosine, and tangent. Better copy this down. What's the point of trig? So on warm-up, let me bring that warm-up page up here real quick here. I want to show you something. So right now you don't have to write anything down. Right now you just have your title, you have your calculator screen in front of you, and you're paying attention. Because I'm going to give you the jewel, the wonder, the glory, the beauty, the majesty of trigonometry now. You're about to learn it. Check it out. Let me erase all these ratios that I calculated except for the sine one. I want to show you something. Watch this. Okay, watch this. So this is a little warm-up triangle. You're not writing anything down. So already you're not following directions, but you're supposed to be locked here. There should be nothing on your screen except for calculator. There we go. I want to stamp you, but I really do. Look what I'm going to do. I'm going to calculate the degrees of this angle right here. I have a protractor right here. Check it out. Let me bring my protractor down. Okay. Let me put here's the vertex. I'm going to put it right here. Let me calculate that angle. Remember we did this a few weeks ago before spring break. Okay. Let me calculate this angle. It's a cool little protractor. Watch this. I'm going to grab this and look at the angle measurements are right here. Let me put this up. So here's 0. Let me move this up. Notice how the degrees are growing. I'm going to measure this angle of the triangle right here, this acute angle. How many degrees is it? Watch this. 52 or 53. I'll just go 53 for now. Okay, 53 degrees. Now, watch this. Look at the wonder and magic. So this angle is 53 degrees. Let me take this over here, throw it over there. So this is a 53 degree angle. Now on your calculator, make sure that you have the degrees button highlighted. In other words, you have radians. Look at RAD, that's for pre-calculus, or degrees. You want to make sure degrees is shown like this. So make sure you do that on yours right now. Make sure you can see DEG, degrees, not RAD, radians. That's for pre-calculus, math 3. So degrees. Now, you guys ready? Notice what I got. When I did the sine of x, this angle, it was the opposite of the hypotenuse, and I got 0.8. On your calculator, go ahead and hit sine of 53 degrees. Instead of x, I'm actually going to replace x with the degrees. What do you get? Hit the sine button, then 53, then enter. What do you guys get? 0.7986, blah, 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 right? Keeps going. But look at 0.79. If I round that to the nearest 10th place, the first decimal, look, it's the same thing as what I got. Okay, so this is really 0.8. Rounding out to the nearest 10th. Okay, now watch this. Watch this. Recall before last week when I was making you draw right triangles with a protractor ruler. This 53 degree angle, watch this 53 degree angle when I draw a right triangle. Okay, if I make it a little bigger, it's still a right angle here. This is still 53. If I make it even bigger, remember we did that together? Or what if I made it smaller? Okay. Even more smaller. What I'm trying to communicate here is the sine of 53 degrees. Look at 53 degrees always stays the same on all the triangles I drew. The sine will always be forever 0.8. Or really, this decimal that goes on forever. So no matter how big the triangle, look, I can make it look infinitely many bigger, or how small the triangle, the ratio of the opposite side to the hypotenuse, opposite side to the hypotenuse, opposite side to hypotenuse will forever, eternally, without change, always be this that you punch in your calculator. The ratio never changes no matter how big or small the triangle gets. Now, knowing that, that's where the power is at. Knowing that the sine of 53 degrees, you just punch it in, is some eternal ratio that stays the same, that never changes. Watch how we can solve problems now. Here's example 1. So you have your title. What's the point of trig? That's the title. What's the point? I'm going to give you the point now. Go ahead and copy this triangle down. I got a big fat question mark on the hypotenuse. I got one acute angle there. So you have your computer off to the side and you have your notes in front of you. Copy this down. So here we go. So I have a right triangle, obviously. This is a 90-degree angle. It's a right triangle. I have an acute angle of 36 degrees. Okay, so far so good. Just out of curiosity, what degrees would be that angle? Argument. How'd you conclude that that angle would be 36? What made you conclude that both acute angles are exactly the same? What would be your argument for that? Now I ask you this question, what degrees is this? It's not a trick question. You should know how to figure out what the degrees of that angle is, with the angle knowledge I dispensed on you a few weeks ago. How would I figure out the degrees of this angle? I know this angle is 90. I know this angle is 36. What does that one have to be? How could I figure that out? Thank you. That's the triangle sum theorem. Remember our 9-branch tree map of all the relationships? One of them was a triangle sum theorem that said, look, whenever you have a triangle, all the angles add up to be 180. So if I know this is 90 and I know this is 36, this has to be 180 minus these two, which would be, anybody got that? 180 minus 90, 54, thank you. So this angle, go to note it on your notes. This angle is a 54-degree angle. Okay? Now, where's the magic now? Watch this. Our goal is to solve for the question mark. Okay? Here's a question mark. We don't know what it is, so for now, just label it X. That's typically what we do in mathematics, right? Whatever's unknown, we ascribe to a variable. Now, this is a hypotenuse, right? Now, can we use the Pythagorean theorem to solve for the hypotenuse? A squared plus B squared equals C squared. Can I use Pythagorean theorem? What do you guys think? Remember we used that in week 1 of the quarter? Could I apply Pythagorean theorem right now to solve for the hypotenuse? What do you guys think? That was week 1, quiz 1, actually. Can I use Pythagorean theorem? Yes or no? Not a trick question. Right now, you should not be looking at your screen. Notice. There's no need to be on the screen right now. On the right. Right here. Can I use Pythagorean theorem? Let's see. So one leg is 7, so 7 squared plus, what's the other leg? What's this side? It's unknown, right? So it'd be unknown squared equals x squared. Look at the hypotenuse. So as it stands right now, I can't use Pythagorean theorem because I only know one side of the triangle. In order to use Pythagorean theorem, a squared plus b squared equals c squared, you need to know at least two sides of the triangle. So the Pythagorean theorem is not helpful right now. You can't do it. But that's where trigonometry comes into the picture. That's where it enters the room now to save the day. And here's how it's going to save the day. Watch this. Okay. We're going to use this acute angle 36 because that's the one that was given. We could use 54, but we'll use 36. So whenever we do trigonometry, it's always from the perspective, from the standpoint of an acute angle. So this 36-degree angle, what side is 7 in relation to 36? Is it the opposite, the hypotenuse, or the adjacent? 7. Opposite. So when I think of SOHCAHTOA, look at what ratios have opposite mention? The sine, cosine, or tangent? Tangent has opposite mention. Where else do you see opposite? The sine. So I have 36 degrees. I have the opposite to 36. So I know I'm either going to use the sine or the tangent. But what side is the x? The hypotenuse, huh? So what ratio has hypotenuse and opposite side mentioned together? Opposite and hypotenuse. Cosine has adjacent hypotenuse. Sine has opposite and hypotenuse. Notice that. So I'm going to use the sine ratio because notice that's the side that I'm dealing with. The opposite, and then I got the hypotenuse. Those two sides, so I'm using the sine. Watch this now. Stay with me. So let me write sine. Remember that's the abbreviation of sine, S-I-N. Sine of 36 is equal to, opposite is 7, stay with me, Ramirez, over hypotenuse is x. Look at that equation. Look at that. The sine of 36 is equal to 7 over x. Okay, we have an equation. We have, remember, an equation is like a balance scale. Whatever you do to one side, you got to do the other. Okay. Now, can someone, why don't you guys just go and hit sine of 36 on your calculator in front of you? What do you guys get? Some decimal, right? Point what? And it keeps going on. 0.5877, it keeps going. So we already know that sine of 36 is some decimal. It's some ratio that never changes. Some eternal ratio never changes. Okay? But we're not going to replace it with 0.57, whatever Vadilo said right now. We're just going to leave it for now. We'll leave it as a sine of 36. In the end, we'll punch it in when we get x by itself. But for now, you need to know that the sine of 36 is some decimal. You just punch it in. It's right in front of you, right? Staring at you on your screen. This is some decimal. Now, when we have an equation with a variable, we have to get the variable by itself. Right now, the variable is not by itself on the right side. I have a 7 next to the variable. So my goal right now is to get that x by itself on the right side. So what I'll do is let's get the variable out of the denominator because it's not helpful when the x is on the denominator. So what I'm going to do is I'm going to multiply both sides by x. Do that with me. Remember, whatever, look, it's like a balance. Whatever you do to one side, you got to do the other for it to balance. What I've done is I multiplied the right side by x and the left side by x. And look at why I multiplied by x. Check this out. 7 over x is a fraction. If I make x into a fraction, just put x over 1. And look what ends up happening. Fenderson? Taking notes right now, right? So I have 7 on the right side. Look at because the x's cancel out. And I have x times the sine of 36 on the left. So notice how the variable is not on the denominator anymore by one little manipulative step. I just multiplied both sides by x. It's no longer in the denominator, so we're good to go there. What's up, second dude? Henderson, can you put the computer more on the desk so the things in the folder? Thank you. All right, here we go. Now, the goal of every equation is to get x alone. X right now is on the left side. Look, it's right here. It's, remember, sine of 36 is some decimal that never changes. So this is really x times some decimal equals 7. How do I get x by itself? What would I do to both sides to get x alone here? What about 7? Well, x is over here, so I want to get rid of the sine of 36. What would I do to both sides to get rid of the sine of 36? Get nothing. But this means times, not x times sine of 36, so we'll do the opposite of. So I'm going to divide both sides by the sine of 36. Yellow? What's up? Okay. Yeah, just leave it. There's no flat. It's fine. No, don't worry about it. It's fine. Bye. All right. So look what we got now. Sine of 36 divided. Look, remember that's some decimal. A decimal divided by itself is cancels out. Look at x is by itself. 7 divided by the sine of 36 is going to be our what x is. So go ahead and type 7 divided by sine 36 on your calculator, hit equal, and tell me what you get. Nice. So everyone should get 11.9 something. 7 divided by sine of 36. 7 divided by sine of 36. 11.9. Seven divided by sine of 36. Right, well that's actually what x is. We just solved for x. So we're going to run the nearest tenth, the first decimal. So x is about 11.9. About. Check it out. Look, we just solved for the hypotenuse, right? That was the division. We solved for this side using trigonometry. We didn't have to use Pythagorean theorem. This side is 11.9. So all we had to work with was an angle in one side, and we're able to solve for the other side using trigonometry. Same thing. Yeah. Okay. Thank you. Gotcha. Got it. Okay. All right. So coming back over here. So we're able to solve for x. What I want to do now is I'm going to solve for x again. Secondino? Oh, no. You're good there? Thank you. So we're officially done with this problem. Example 1, we're done. What I want to do is I want to solve for x again, but using the other acute angle of 54 degrees, just to show you, you still get the same answer no matter what acute angle you use. So the first way we did it, we used the 36-degree angle. Now I'm going to use a 54-degree angle to solve for x again. So I'm going to do it in red here. So we're still in example 1. I'm just going to do it again, just for enrichment purposes. So this is 54 degrees. We found that out. Remember, all the angles add to be 180. Now, let's say this is x again. Let's use trigonometry, but from the 54-degree angle. We'll still get 11.9 is what I'm trying to communicate here. Watch this. So 54 degrees. This side is, look at the side 7 now. Side 7 is what in relation to 54? Is it the opposite? Is it the adjacent? Or is it the hypotenuse? It'd be adjacent. So I know that Adjacent is mentioned here for the cosine. It's also mentioned in the tangent. But let's keep going. Side x is the hypotenuse. So I'm dealing with, if I use the 54-degree angle, I'm dealing with the adjacent and I'm dealing with the hypotenuse. So what ratio deals with adjacent and hypotenuse? The cosine. Look at adjacent and hypotenuse. So if I'm going to use the 54-degree angle, I'm going to use the cosine. So cosine 54 is adjacent would be 7 over hypotenuse would be x. So adjacent over hypotenuse. And now we're back to kind of what this equation was. But we're just dealing with the cosine of a different angle. But let's get x by itself just the same way we did. X is in the denominator. So what I'll do is I'll multiply both sides by x over 1. Look at this. Whatever I do to one side, I got to do the other. So I'm multiplying both sides by x. That gets rid of it. Check this out. By to x on the right. So all I have is 7 on the right. On the left, I have x times the cosine of 54. X times the cosine of 54. So I'll divide both sides by the cosine of 54 to get x by itself. So cosine of 54 divided by cosine of 54 is gone, so I have x alone. And now go ahead and type this in your calculator. 7 divided by cosine of 54, you should get 11.9 again. Same thing, just from a different angle perspective. $11.9. That's the beauty of trig. It's a beautiful science. Gives me the chills. It's so beautiful. Okay. This is Monday. I'm only going to go over one more example. That was example 1. Just one more example. Any questions on this, by the way? Sure. I'll post a video too up on Google. So the first way we did it was using this acute angle, 36. So we used the sine. The second way we did it is use the other acute angle, 54. That one we use the cosine. It's still the same answer. One more example. Example 2, and we're done for the day. There we go. I'll write that one down. Let's solve for h. So, let's solve for h. Let's solve for h. Right here, this side. We can't use Pythagorean theorem, a squared plus b squared plus c squared, because we only know one side. Look at, we only know the hypotenuse. So we can't use Pythagorean theorem to solve for that for h. But we know this angle, this acute angle is 30 degrees. And we know this acute angle would be what? 180 minus 30, 60. This would be a 60-degree angle. Go ahead and put that in your picture. So look at the logic I used. That was our angle relationships knowledge from about 2 or 3 weeks ago. 180 minus these two gives me that one, because they all add up to be 180. So I know this is a 60-degree angle, 30-degree angle. Let's rock and roll. Now, I'm looking, the goal, the mission is to solve for h. All right? Solve for h. Now, what is h in relation to 30? Let me think of SOHCAHTOA. SOHCAHTOA, let's dip our sushi in this puppy. What is h in relation to 30? Opposite. So let's see, opposite is mentioned in the sine, opposite is mentioned in the tangent. Let's keep going. What else are we dealing with? We're dealing with the hypotenuse. Look at, the hypotenuse is given. The side opposite is what we need to find. The side hypotenuse is what they gave us. So it's kind of like when they deal with your cards. You got to play with the cards you're dealing with. So we are dealing with the opposite, and we're dealing with the hypotenuse. Look at. So we're going to use the sine ratio. Notice that. Put them on the desk. Thank you, Castro. So we're using the sine. There's only three ratios to choose from, sine, cosine, or tangent. I'm using the sine because I'm dealing with the opposite and the hypotenuse. So look at the way I'm going to set up the equation. The sine of 30 degrees, it's always of an acute angle. Remember, that's going to be some decimal, some eternal, non-changing, forever invariable decimal that never changes, no matter how big or small the triangle gets. This is some decimal, equals opposite, SOHCAHTOA, opposite over hypotenuse. Opposite of 30 is h, hypotenuse 52.6. Let's do this. This equation is slightly different because look at the variables on the numerator. It actually is easier. Whenever you're having this situation, it's easier and quicker. I don't have to multiply both sides by h. All I got to do is get h by itself. What can I do to this equation to both sides to get h by itself? Anybody have any ideas? I got to do something to both sides. To get h alone, what do I do? By? Beautiful. Nice. Let's get rid of that 52.6 by multiplying by 52.6 on both sides. Good job, Modelo. 52.6 again on the left and right. See, right here and on the left. Look what ends up happening. I'll make 52.6 into fraction because h over 52.6 is a fraction and put this underneath the 1. Look what ends up happening. I'll bring down the equal sign. These cancel out. I have h by itself, which is our goal of any equation, to get the variable by itself. And now look at it. I'm just going to type this crap in my calculator. 52.6 times the sine of 30. Go ahead and type down your calculator and run it here. 52.6. You don't even have to put the times symbol. Just put 52.6 sine 30. What you get, Fenderson? What you get? Oh, I thought you typed it in right now. Go ahead. Nice. Anybody different with Monroy? No, we're good. Same thing or no? 26.8? What'd you get, Priscilla? You got 0.8? Try it again. I got two people with 0.3. Something happened. Got you. Got you, got you. That'll make all the difference. So h is 26.3. So this side right here, look at, we've solved for it, is 26.3 h. Okay, just for giggles, I'm going to do it again, but using the other acute angle. We use 30 degrees. I'm going to use a 60-degree angle now, just for enrichment purposes. Here we go. I'll do it in red. So we're officially done. We're done with the mission. We solved for h. But let me do the 60-degree angle and notice the different ratio I'll use for this one. Watch. Here we go. So I'm using the 60-degree angle. With 60 degrees. I'm solving for h. Thank you, Monroe. Here we go. So that I'm solving for h. H in relation to 60 is the adjacent. Look, it's touching it. It's adjacent. So I know when I deal with SOHCAHTOA, I'm looking for the ratio that has adjacent in it. Let's see, SOHCAHTOA, which one has adjacent? Well, cosine has it, and the tangent has it. Let's keep going. Let's see which one I'm going to use. So I'm dealing with the adjacent to 60, and I'm dealing with the hypotenuse. So which one has adjacent and hypotenuse mentioned? Cosine. I'm using cosine again. So let's go cosine now. Look at the equation now. Cosine of 60 is h over 52.6. Look at the equation. It's a trigonometric equation. That looks mighty similar to the one we just did. Okay, h is on top, so let's get h by itself. We want to get h alone, so let's get rid of the 52.6 by doing the same thing we did the first way in blue. We'll multiply both sides by 52.6, which is the same as 52.6 over 1. I'll multiply the left side by 52.6. Divide by that. I've got h equaling. Just type that crap in. You should get 26.3 again. If you type in 52.6 cosine 60, hit equal on your calculator, it'll do it for you. We solve for h once again. This is powerful. Powerful science, you guys. Potent.